Hey everyone, today let's try to solve a problem called Cowpatibility. In this problem, you are given a list of cows, and each cow will have exactly 5 flavors of ice cream. For example, this 1, 2, 3, 4, 5 means they like ice cream 1, they like ice cream 2, ice cream 3, ice cream 4, and ice cream 5 for this cow one. There are 4 cows in this particular input, which is identified by the first number. So what we want to output is the number of pairs of cows that are not compatible. What do you mean not compatible? It means there are 2 cows, cow I and cow J, and each of them will have 5 flavors that they like. And then if none of the flavors they have are in common, then they will be incompatible. And we just need to return the number of pairs in total that are not compatible. For example, cows 1 and cow 3 in this example is not compatible because cow 1 likes 1, 2, 3, 4, 5, and cows 3 like 6, 7, 8, 9, 10. So nothing in common. So it's not compatible. And so on and so forth. That's pretty much all for the problem description. And let's think about how can we approach the solution. So first thing first, instead of thinking how to find the incompatible cows, let's think about how to find the compatible cow that one cow can have. If you can find a compatible cow, and you can essentially also figure out incompatible cow pretty easily. For example, if you are iterate cows from 0 to n-1, which is their index, and then I will be the number of cows that are already visible. So compatible cow will be the number of cows that are compatible with this cow I. So the incompatible cow will just be I minus compatible cow. Assuming I is the visited cow count, which is also the index if we iterate the cows from 0 to n-1. But how can that help us solve the problem? Take a look into. So we can consider using inclusion-exclusion principle to calculate the compatible. Let's begin with something simple. We don't think about ice cream flavor equal 5. The ice cream flavor is only limited to 2. In that case, how will you find the compatible count for particular cows I that we have just visited? So assume I1 is the first ice cream flavor, and then I2 is the second ice cream flavor, and I1 will be the frequency or the number of cow that likes I1, and I2 will be the number of cow that likes ice cream 2. So the compatible cows will be the number of cow that likes ice cream 1 plus the number of cow that likes ice cream 2, but minus the number of cow that like them both. Because when you look at this diagram, you add ice cream 1 and then you add ice cream 2, and then you will realize that this middle part counted twice. So that's why we have to minus this back. That's the basic idea of inclusion and exclusion. So let's take a step further and consider what if the total ice cream flavor is 3 instead of 2. In that case, compatible cows for cows I will be cow I1 plus cow I2 plus cow I3, which is basically this 3 circle, and then minus cow I1 I2, cow I1 I3, cow I2 I3. Basically, you can imagine it is something like 3 choose 2, because we have I1, I2, I3, we want to choose any combination of size 2. So in the graph, this that I'm circling, and then also this I'm circling, and also this I'm circling. That will be the second layer, because we mentioned before this will be the thing that we overcount, and then we have to subtract that. And then there's another level if we do something like this, which is I1, I2, and I3, which is in the middle. So you can see from the diagram, it is subtracting more than necessary, so we have to add them back. So that's the basic idea. Of course, this is not the final answer because it's only the ice cream flavor up to 3, but you get the idea. If we just extend the idea from 3, 4, and 5, of course, the formula will be a bit more complicated, but essentially it's just the first level is 5 choose 1, and then the second level will be 5 choose 2, because we have to pick any combinations that have a size of 2, and then third level will be 5 choose 3, and then fourth level will be 5 choose 4, and then fifth level, which is 5 choose 5, which is just I1 and I2 and I3 and I5. So each level first is plus, and then second is minus, and then again plus, and then minus, and plus, which is exactly how it operates in inclusion and exclusion principle. So once we have this formula, then it's actually pretty easy to come up with a solution. So once we have this formula, and we can actually write our code to implement that. So let's see how can we implement that in Python. Let's take a look at code. First, we are going to import some library. In Python, there's a very useful library for solving this problem. It's called combination, which basically will tell us order combination given a list and a size, which is exactly what we want. So we can shorten the code considerably. And then first we're going to read the input, and then we have to sort the input as well. Because when we are talking about ice cream flavor 1, 3, it should be equivalent to 3, 1. And 1, 2, 3 should be equivalent to 3 to 1, so on and so forth. That's why we just shorten, and then every tuple will be the same. And after that, we just iterate for every cloud. And first we're gonna include the answer, and then for each step, we just toggle the inclusion boolean value. So the first size equal 1 will be include, and then size equal 2 will be exclude, and then size equal 3 will be include again, and so on and so forth. In this loop, we're going to find all the combination for this ice cream with this size, and then we convert this combination into a key in our frequency dictionary, and then the compatible count will be incremented by this frequency if it is inclusion, and if it is not inclusion, then of course the compatible count will be minus. So after calculating everything in this loop, the compatible will be the number of cows that are compatible to this cow's I, but we don't want compatible, we want incompatible. That's why we have to I minus compatible, calculate the incompatible count, and then add that to our answer, and eventually just print out the answer. As you can see, the code is not too bad because it can make use of this combination library, which makes the code really easy to understand, in my opinion. So that's pretty much all. For the time complexity, it will be ON. As you can see, we are looping in here. And for each size, we are going to do 5 choose 5, which is the last size. And then 5 choose 4, 5 choose 3, 5 choose 2, and 5 choose 1. But you might argue that all of this is just constant. So you can just say that it is just ON, or state complexity will be ON. That's pretty much all. Let's try to submit the code. Okay, our test case passes, and I hope you find this video helpful, and I will see you next time. Bye bye.